Hey everyone, welcome back to my channel. So today we're going to solve search in rotated sorted array. So we're given the integer array nums sorted in ascending order with distinct values, which means there is no identical values in the array. So the array is possibly rotated at an unknown pivot index k. What it means? So for example, we have an array from 0 to 7, and it is rotated at pivot index at 3. So basically we will just rotate from the 4 to 7 and swap it into the left portion. The result will become 4 to 7 and 0 to 1, and we will have two portions. We will also be given an integer target. We will determine whether this target is in the input array. So how are we going to do this? So the most straightforward way to approach this problem is just literally check every number in the array and compare with the target to check if it's equal to the target. But it will not very efficient. We need to create an efficient algorithm that runs in log n time. So remember, we have learned to use binary search for a given sorted array. Can we directly use that for this problem? We have mentioned that there were so many variations for the binary search, and this one is one of the variations. Let's see how we can use this. So how are we gonna solve this by using the binary search? Because binary search is an efficient searching algorithm, we want to directly applying this algorithm on our problem. Binary search is feasible on the array with regular sorted numbers. So what if we can separate the original array into two portions that is totally sorted and can be applied for binary search? So there is a simple pattern that inside index, which the array is rotated, current number will be larger than the next number. So we can basically use a for loop to check if the current number is smaller or larger than the next number. And then we will assign the end and the start to denote different portions. As we can divide the array into two portions, we can separately use the binary search to solve the problem. So remember that we will have 3 pointers for binary search, which is left and right. We will use the left and right to calculate the midway pointer. So for the left portion, the index 0 will be the left and the end will be the right, and it will calculate the midway pointer. And for the right hand portion, the left will be the start and the right will be the element in the end. So basically we will run binary search for these two portions, and if the target is in the initial array, one of the portion will return -1 and another one will return the index in the original array. As mentioned in the problem statement, that the array is possibly rotated. So the input array could be not rotated. Say the 0 to 7 is not rotated. And how are we going to do this? We will just basically use the for loop to check if there is a violation, and there is nope. So we will basically just conduct the binary search for one time. So let's look into the time complexity. So as we use a for loop to check if there is a violation for the rotation, the worst case will be check every number, so that will be on. And if there is a violation, and we will just conduct binary search and break the loop. So the binary search we will conduct 2 times. So every time we'll run in log n, so that will be 2 times log n. For the worst case, input array is not rotated, we will just check every number and conduct binary search for one time. So that will be O(n) time. Also, I want to mention is that there is another solution to this problem, which is introduced by LeetCode 4 years ago, and we can simply check this in the description. I attach a link to that, and I appreciate that. It was a very decent solution to this problem, and it always run in log(n) time. Okay, let's code it up. So, like what I said in the previous video, we can use the binary search directly into this problem. So we will quickly implement the binary search. If you didn't remember that, or you feel a little lost in catching with this video, you can look into my another video, which is the 704 for the binary search one. We will directly use that implement for this problem. Because we will conduct the binary search for two portions, we will implement the binary search directly in this problem. And we will pass in the sorted array and the target into this function. So we will have two pointers at first, which will be the 0 and the length of the sorted array. We will modify this later, but we'll just keep this for the sake of align with the previous videos. And we will have a while loop. The left should be always smaller or equal than the right. And we need to make sure that the left will not cross the right. And in each iteration, we will have a midway pointer, which is left plus right, and divided by 2. And if sorted array, the mid pointer number is smaller than the target, then we will say we will eliminate the left portion. So the left will be mid plus 1. Similarly, for the other part, if the mid number is larger than the target, we will just narrow the search range by move the right to the mid. The else case is just that the sorted number is equal to the target. So we'll just return the mid, which is the index of the target. If we run all the iterations and we didn't return the index, we will just return -1 to indicate that there is no target in the array. So this is binary search. It's just basically the equivalent to what we did in the binary search problem. As what I said in the drawing, we will just have a for loop to check the rotation violation. So we will literally have an index number in range of the length of the nums. If the current number, so we will start from the 0 and to -1 to ensure it will not out of bound. If the current one is larger than the next one, we will see that this is a violation. Then we will denote 2 pointers and then start. That will be equal to I and I plus 1. So we basically conduct the binary search for 2 times for different range or different portions. So in this case, the left pointer and the right pointer is not the 0 or the length of a sorted array. It will be different, and we will assign it manually. So we will refine it a little bit to move the left and right into the arguments of the function. So for the first portion, we will assign the 0 as the start and the end as the right pointer, and also pass the sorted array into the function and the target. We will denote it as the first part, first half. So if the target is in this portion, the first half will return the index of the target, or it will just return the -1. Second half is literally the same thing. Which is different is that the left pointer will be the start, and the right pointer will be the length of nums. Sorry, there is a typo here. It should be the nums, not the sorted array. The nums. So it would not be the sorted array, it would just be the array. So, okay. This is great. So we will check if first half or second half has the valid return value. If the first half is not equal to -1, then we will return first half. We will conduct the same thing for the second half. And there is just one rotation index in the array, so if we find it happens one time, we will just break the loop. And if we have returned the index, we will just stop here, right? So what if the array is not rotated? So we will not enter this if condition. Basically, we will just write a binary search out of the loop as a backup. The start will just be the 0, and the right will just be the length of the nums. And we can see the result. There is typo here. It should not be the length, but the length -1, or it will be out of bound. There is a small typo here. We should not use the break here, because if we detect there is a rotation in the array, and there is the array not return the index, it means that there is no target in the array, so we will just return the -1. Yeah, it will not affect acceptance of the test cases, but it will just like some minor bugs.